Hello, everyone. Hello, everyone. And today we are, well, by now we have reached the culmination, the key moment of the IRS, the project presentations. But before we begin, let me give you some rules and regulations. Let me remind you about them. First of all, please make sure that your microphone and the camera are turned off, and only when you speak, you turn them on. And please change your name in Zoom according to the way it is given in the instructions, which you can see on the screen. Thank you very much. Secondly, well, there is one more. There is one more. What else? Yes. Yeah. When you want to speak, you need to raise your hands. So you'll find your name in the section participants. Then you click raise hand and raise your hand. There is an instruction which you can also see on the screen. And now I would like to pass the word to Ksenia Salnikova, who is the director of the IRS, and she will say a few words and present the expert who is going to evaluate the project presented today. Ksenia, you're welcome.
Thank you, Roman. A small correction, we do not have any evaluation today. Today we gathered only for discussion of the work that have been done by our brilliant students from all parts of the world. So, dear students, dear delegation leaders, dear tutors, experts, and guests, I'm very glad to welcome you at this first part of the project presentation session of the International Research School 2021. We gathered here to see and discuss the work that our students have done over the past 9 days. It was a great experiment for them and for us as well. No one has ever done this before you. I mean, working on projects in international team, overcoming distance and time differences. You know, it was a unique story so far. It was a challenge that you have accepted. And today, many experts and guests joined us to listen to you, and they're all very interested and excited. So let me introduce them. You know, when I introduce experts at normal IRS, I mean in the IRS that we call the in offline mode, I usually ask them to stand up so all the participants could see them. But today in online project presentation, I would like to ask our experts, when I pronounce their name, to switch on the camera and the mic, and I don't know, to give a wave to participants, to say hello, to greet them, so they can see you. So let's start. Irina Repina, Doctor of Science, Professor, Head of the Laboratory at the Obukhov Institute of Atmosphere Physics of the Russian Academy of Sciences. Irina, are you here with us? She probably will join us later, so let's move to the next expert. Next expert, Timofey Orlov, PhD, Senior Researcher at Sergeyev Institute of Environmental Geoscience of the Russian Academy of Sciences. Timofey?
I'm here.
Timofey.
Yes.
Nice to see you. Thank you for joining us. Next expert, please. Ivana Gapkin, junior researcher at Vernadsky Institute of Geochemistry and Analytical Chemistry of Russian Academy of Sciences. Ivan, are you here with us? Okay, probably Ivan will join us in a moment. Next expert, Andrei Kirsankin, PhD in Chemical Physics, Senior Researcher at Bykov Institute of Metallurgy and Material Science, Russian Academy of Sciences. Andrei,
Yes,
please show up. Andrei is here. Let's proceed. Next expert, Tatiana Vompi, PhD, working in Bykov Institute of Metallurgy and Material Sciences, Russian Academy of Sciences. And Tatiana is also General Secretary of Milset Vostok. Tatiana, are you here? Please show up. Yeah, Tatiana is here. And next expert.
Tatiana here.
Hello, Tatiana. Our next expert, also sitting in a special expert room, Yulia Gorelova, Director of Nonprofit Partnership for Promoting Ornithology Development, Birds and People. Hello, Yulia. And next expert, Andrei Kashurnikov, PhD and leading researcher at Lomonosov Moscow State University, Faculty of Geology, Geocryology Department. Andrei, can we see you? Andrei Viktorovich.
Hello, hello.
Hello. Nice to see you. Let's move. Sergei Levitsky, PhD and senior scientist at Lomonosov Moscow State University, Faculty of Biology, Molecular Biology Department.
Кричи сюда, Сереж.
Hello. And our next expert, Alexander Pestich, tutor at Lomonosov Moscow State University High School. Alexander, are you here? Probably Alexander will join us later. Let's move. Tatiana Ignatenko, teacher at Lomonosov Moscow State University High School. Tatiana, can we see you? Yeah. Hello, Tatiana. And our next expert, Olga Prudkovskaya, Practices of Future Project Deputy Head, National Technology Clubs Association. Olga.
Hello. Hello, Ksenia. Nice to meet you.
Nice to meet you. Next. Expert Anna Makarchuk, PhD in Psychology, Director of Moscow Jewish Museum and Tolerance Center. Anna, can we see you today? Okay, let's proceed. Probably we see Anna later. Valeria Vladislavskaya, PhD in Psychology, Professor at Russian Presidential Academy of National Economy and Public Administration. Valeria?
Yes, hello, I'm here.
Hello.
Hello.
Next expert. Yelena Stevanovich, lead specialist for rheological characteristics and classification of crude oil at Science and Technology Center, NIS Naftogaz, Novi Sad, Serbia. Hello, Yelena. And next expert is from Council of Europe, dear Vuk Vukovic, Doctor of Chemical Sciences, Scientific Assessor for Control of the Quality of Medicines, European Directorate of the Quality of Medicine and Healthcare, Council of Europe, Strasbourg, France.
That's correct. Thank you for your kind introduction. Hello to everyone, and especially to all of you whom I didn't see for a couple of years. It's very, very good to see your faces again, although remotely, but I hope to see you in Moscow at some point soon. And hello to participants as well, to everyone. Hi.
Thank you very much, dear Vuk. We're also very happy to see you, to have you with us today. Let's move. Danica Despotovich, Master of Sciences of Electrical Engineering, PhD students in Neurosciences, the Vision Institute, Sorbonne University, Paris, France. Danica, can we see you? Danica, are you here? Okay, maybe Danica will join later. And our next expert, Alexei Obukhov, PhD in psychology, professor, leading expert, Institute of Education, National Research University High School of Economics, Moscow, Russia, and of course, the scientific director of International Research School. Alexei.
Здрасте, здрасте.
Hello. Next expert, Ivan Smirnov, PhD in biology, deputy director for teaching and educational work, and biology teacher at St. Basil the Great Gymnasium. Ivan.
Hello. Nice to see you.
Also nice to see you. You have a nice view ahead. Next expert. Okay, I think that's all. I know that more experts joined us. For instance, Juan Alberto Guevara from Mexico. Juan, are you here? Probably later. So our experts who joined us not long ago, they will introduce themselves when they will ask questions. So thank you very much, the expert. And there are a few more experts who represent the organization that are supporting the International Research School and who would like to welcome you today. I'm happy to invite to the microphone. Next slide, please. To invite to the microphone, President of Milset Vostok Regional Department, Head of All Russian Movement of Creative Teachers, Researcher, and Principal of Lomonosov Moscow State University High School.
Dear friends, hello. I'm very happy to see you, all of you, this day, because it is a very famous day when you represent the results of your project work last few days. International Research School is an unique project because it gives opportunity to work together, not to show only the results of your work in your countries, your schools, but it is joint work. And in this joint work, we can understand each other better and to make joint plans for future collaboration. It is very fantastic. So your projects carried out in different branches of science and technology, and International Research School gives the opportunity to work in the pilot direction of science. And maybe this work gives you the opportunity to imagine your future way in science and in science, in professional, and in your life, in future life. And such project is real because of efforts of joint efforts, many organizations and partners, and of course it is all Russian movement, the researcher. It is Milset. It is of course Moscow State University and Moscow State University High School, which provides some additional opportunities, technical and science opportunities to for the International Research School, and many other partners in different countries. Of course, it is Yakutia, which with Yakutia we will have the International Science Games next year, and many other interesting projects. And today we will happy to discuss your presentations of your projects, and more than 40 experts will discuss with you the results. And I believe that many of you will give the imagination of next step in your work, in your collaboration. And I think that it is the main sense of today's event. I wish you successful participation and further collaboration and cooperation. Thank you very much.
Thank you very much, Alexander. And let me introduce our next speaker, Alexis Fidessave, President of National Technology Clubs Association. Alexei.
Hello. Thank you very much.
Hello.
My name is Alexis, yes, and I'm as a president of Kruzhok Association, how we call it, Kruzhok Association. Yes, I'm proud to organize and participate today in this research contest. Our organization is a non-government organization, and we support an ecosystem of technological enthusiasts in Russia and in previous Soviet republics and countries around the Russian Federation. And we run many activities for school children and university students, like National Technology Initiative Contest, and we run project-based schools and hackathons, and we train mentors to help supervise school children's projects. And I think that today we have the brilliant activity for school children and students who want to work with real projects and real researchers. And actually, I totally support the speech of Alexander Leontovich, and I hope that it is actually a global event for all of us. And I think that today, when we see the globally divided world, in many senses, we are divided actually and mentally. And I think that such research activities, projects, and international communities are able to fill this gap between countries, between cultures, between research practices, and etc. So thank you very much, and good luck for all of you. Thank you.
Thank you very much. Thank you very much for wonderful speech. Just a small note. Today we do not have any contest. It is very important for participants, for our students. Do not take it as a contest. We do not have any evaluation. We will not compare you. Our goal today is to listen to you, to discuss your results, and to give you a productive feedback. So thank you very much. Let's proceed. Our next speaker today, Alexei Golubitsky, Principal of School of the Future of Kaliningrad region. Alexei, please.
Hello, Ksenia, hello, experts and participants. Thank you very much. And first of all, I have to say that it's a privilege to be here together with you today. And I was a scientist in the past before I lead the school. So being a marine geologist, I have to say that I'm sure that investigating the world is the most exciting and useful business that you're able to find in any sphere. So I know that you have been worked hard for the last few days, and I wish you good luck with your presentations.
Thank you very much. Thank you very much, Alexei. Let's proceed. And final speaker today our great friend of IRS, General Director of Foundation for Future Generations, and former Minister of Science and Education of the Republic of Sakha-Yakutia, Vladimir Yegorov. Please.
Dear participants of the 13th International Research School, I have been fortunate enough to have hosted 2 consecutive international research schools in 2017 and 2018 in Yakutia in my capacity as the Education of Science Minister of the Republic of Sakha-Yakutia. It was wonderful experience for the Yakutian children, for the children from the other countries, and the Sakha Junior Science Academy now organizes a similar event for local children every year. Now I had a charitable foundation, the Future Generations Fund of Republic of Sakha-Yakutia, which supports many educational projects. This event not only allows you to build your skills, but it also gives you an opportunity to work together through collaboration and networking. We believe that science brings people together, and by working together through this joint effort, we can create a good global citizenship. This philosophy is what drives us forward. We organized the first Yakutian International Science Games in 2018, and the International Research School was a key, very successful event in these games. And now I would like to invite you all to the second Yakutian International Science Games in 2022. We will send invitations through the organizers of the International Research School. I hope to see you all at the games either virtually or in person. Let me again wish you all the best in your scientific journey and in building strong friendships and networks.
Thank you very much, Vladimir. Thank you for revealing us a secret. Now we all know that next International Research School will be a part of International Science Games in Yakutia. And I think we are all looking forward to have an International Research School in offline mode in such a wonderful region. So thank you very much. And let's proceed. We are moving to the most important part of the project presentation, and let me pass the mic to Roman Beck.
Thanks, Ksenia. But before we actually proceed to the presentations themselves, let me say a few words about the way it is going to go. Well, first, you will see the presentation itself. It will last for approximately 10 minutes. Then you will have 20 minutes to ask your questions. But in the strictly following order. First, it is the participants, the students, who have the opportunity to ask questions. And only then come experts, delegation leaders, and tutors. Well, to ask your questions, please raise your hands. I think you know how to raise your hands in the Zoom. Well, but even if you don't have the opportunity to ask your questions, there is a feedback form. As soon as you see that the presentation has begun, you will see the QR code, which links to the a small questionnaire, a small feedback questionnaire, which we urge everybody to fill in, because it is important for the presenters, that the participants, to have a feedback from you, naturally. And well, if you find it inconvenient to use the QR code, we will definitely send a link to this questionnaire in the chat, and you will see it. So even if you plan to ask a question, please fill in the questionnaire anyway. It is very short, only 3 questions. Okay, then thank you very much, and we can proceed to the first project, which is called Antimicrobials, the Infinity War. Yeah, now you can see the QR code. Please copy it and go to the link. And in the chat, you can see the link to the same questionnaire. Okay, I'm turning my microphone off. And I give the word to the members of the project Antimicrobials, the Infinity War. Are you ready? Okay, the tutor is saying yes. So, okay, let's begin.
Hello, everyone. We are here to present to you the result of the project AIW, or as you know it, Antimicrobials and Infinity War. Next slide, please. Here we are going to talk to you about everything we understood in this project, from interactions, lesions, and everything. This project, in this project, we are looking for new potential drugs. Don't worry, we are not in Breaking Bad. And by drug, I mean medicine and medications. The pill you take when you feel ill or you feel sick.
Medicinal chemistry is a part of chemistry which goal or objective is to elaborate the chemical synthesis and the development of new drugs. Also, there is the computational chemistry, which is a branch of chemistry. Obviously, it helps to save time and money. It uses the computational simulation to assist in solving chemical problems based on the complex mathematical calculations that a computer has. The target has proteins. Proteins are the biological targets of drugs. There's an example, 6O4X.
Enzyme, in simple words, it's a catalytic protein produced by the cells of the organism, which promotes and regulates biochemical reactions. Ligands are so small organic molecules capable of interacting with biological targets, for example, proteins or DNA. It can set a signal by binding to the active center of the protein. EDME are properties that define what will happen to the drug when it is injected into the body. These are important because if the ligand has a good EDME properties, it means that it has a high degree of similarity to the commercial drugs. EDME, in simple words, is the pathway to the drug in the body.
So here are the tools that we use to construct brand new molecules. It's Biovia, Chimera, Autodoc, and Avogadro. For the docking process, first we designed our ligand and looked for the mistakes so we could fix it. Then we checked the docking poses that program gives us. And finally, we checked the interactions of our ligand and our enzyme. The topic selected for this project is to target bacteria and design new potential drugs with the help of medicinal and computational chemistry using different computational chemistry techniques. Our 2 target enzymes are included in the biosynthesis of bacterial proteins, and inhibition of these enzymes would affect bacteria growth and eventually would lead to bacteria death.
Our first target enzyme is tyrosyl tRNA synthetase, responsible for bacterial cell growth. Our goal is to design and test ligands or compounds that will inhibit its function. So we designed 14 novel compounds using the coumarin as a template, which is a known inhibitor of the said enzyme. On the next slide are the best compounds are in the dotted boxes. We'll see later why they are deemed the best drug candidates. On the next slide. Okay, so one important property in designing molecules is the affinity or the sum of the intermolecular interactions between the compound and the target enzyme. So the best compounds we have are in green boxes and have around -10 kcal per mole, which is a good value. Again, these are the best 4-level compounds because of its good affinities and chemical properties.
So in the enzymes, ligands are bounded non-covalently. So here you can see how our compounds are interacting with the enzyme, which was our target. So in order to create better biological response, we need to understand how all these interactions between the compound, the molecule, and the enzyme is happening. Here you can see strong hydrogen bonds, which are colored green. Also, you can see the interactions between aromatic rings, which are called PP interactions. And here on this slide, you see all these interactions, but in the 3D mode. Also, you can see our molecule and how it fits in the enzyme. And our compound number 1 which shows the best result, has gastrointestinal absorption level higher than every other molecules, which means that it can be taken as a drug easily.
Regarding target 2, we worked with an oil reductase IN8A enzyme, and we create 14 different compounds based on the reference compound that you can see here. Next slide, please. Here you can see the compounds we create, and the ones in the box are the best ones. You'll see now why. To see these compounds could be a potential drug, we calculate their affinity between the compounds and the enzyme, and the ones are in green are the ones with the best affinity.
Here on this slide, you can see the best 4 compounds for target 2. I want to mention that all these compounds went through SciFinder database, and based on this search, our compounds are new.
Also, here you can see the interactions the compounds have with the enzyme in 3D, and you can see that the compounds we made that are the red ones and the green ones that are the reference compounds are almost in the same place, so that means are in the active cavity of the protein.
Here we can see how the compounds for the target 2 interact with the enzyme. Again, we see strong hydrogen bonds and PP interactions between aromatic rings.
Not only we calculate the affinity, but also the ADME properties. And you can see that our third compound is the best one to be a drug. And even the most potential drug has gastrointestinal absorption low, is still a good drug.
So, as in conclusion, we designed 28 compounds for 2 targets. We chose 4 of them for each target. And at the end, we have the 2 best compounds for each target. For the first compound for target 1 and third compound for target 2. It's important to make a computational chemistry process to know the properties of different enzyme molecules, so they can be considered as a potential drug. Next slide, please. Also, there are a lot of opportunities to create new potential antibiotics that can treat bacterial infections. That's what we're trying to do. And here we created molecules within the only known limit was our imagination. And it's very useful to know basic of different branches of chemistry, such as computational and medicinal, for the health and medicine development nowadays. Thank you for your attention. This is AIW project.
Hello, thank you very much. Thank you very much. That was really very interesting to listen. Well, this team was probably the largest and the most international of all. Well, the differences between the easternmost people from the Philippines to the westernmost people from where? From Chile is how many hours?
13.
13 hours, yeah. This is the tutor, Ivana. Hello, Ivana. Can you introduce the participants to us so we know which countries they are from?
Okay, so we had 14 participants, Sepanta from Iran, Victoria from Chile, Asal from Iran, Suri from Mexico, Vanya from Mexico, Brenda from Mexico, Angeline from Philippines, Varvara from Russia, Moscow, Russia, Maxim, also Moscow, Adelina, also Moscow, Marina, Moscow region, Sofia, Moscow region, Raquel, Spain, and Tesnim, Tunisia.
Yeah, that's really impressive. Okay, now, ladies and gentlemen, the participants first. You are welcome to ask your questions. Please raise your hands. We have no questions from the participants so far, but we have one question from an expert. 2 questions from experts. Three questions also from an expert, yeah? No, quite good. Okay, please, the participants, the students, don't be afraid to ask questions if you have them. We have, oh no, that was done by mistake. So we have 4 hands from experts and none from the participants so far. Okay, we can't wait for any longer. It was Vuk, I think, who raised his hand first. Vuk, you are welcome to ask your question.
Thank you. Thank you very much. First, I would like to say that congratulations to the team, to the group of experts and participants that were working on this very demanding, difficult project. Also, within these conditions, taking into consideration that working remotely is very difficult. So congrats on that, and congratulations for nice presentation and for the fact that you respected the fact that you should present in 10 minutes. This is really highly appreciated. You also addressed all main points of your research, which was also very good. And the topicality of, well, this topic is really like good. This is interesting and hot topic in science. So really all nice words about that. I would like to ask a couple of questions. So first question is when you want to, let's say, treat a bacteria These enzymes for which you found optimal inhibitors, right? So there are some enzymes from bacteria. So when you want to treat, to give an antibiotic to some human being, to a man, what do you think, what would be possible side reactions? What kind of, so when you're giving this antibiotic treatment to someone, is there anything else you should give to a human being together with this antibiotic? So does anyone have an answer to this?
Thanks, Luke. Any answers from the participants?
Obviously, in a human body, we have to consider the ADME properties. So there you include a probiotic, so it reduces the impact that the drug is causing to your body.
Yes, so if I'm not mistaken, yes, of course, ADME properties, but also you mentioned probiotic, right?
Yes.
Yes, that is really important, because by giving antibiotic, you can also kill good bacteria that also have very obviously good, let's say, functions in our gastrointestinal tract, which leads me to my second question. You said that gastrointestinal absorption is low for one of your compounds, but it is good for, for tyrosyl tRNA synthetase, you found optimized structure that had good gastrointestinal absorption, but it was bad for the another one, an oil reductase. So what do you think, what would be better for killing bacteria in gastrointestinal tract, to have good or bad absorption?
Your answers, please.
Well, it can be a gastrointestinal absorption, but also it can be given intravenous or perhaps.
Yes, very good. So actually, depending on the intended use of a drug, you will have different properties that you will look at. So if there is intravenous route of distribution, of course, you will be looking for, let's say, perhaps, yeah, not absorption in gastrointestinal tract, but let's say this is very good answer to this question. And also the last question that I have is, what do you think about side effects? So you're giving a drug, antibiotic, it should kill some bacteria, but then what do you think, can it do something else in the organism? Because in the beginning of your presentation, you said that proteins are biological targets of drugs. So is this completely correct? Can we have perhaps other targets for drugs in our organisms?
Yes, it can interact with other proteins, the DNA.
Yes, that's correct. DNA, or like some other targets. So in this sense, DNA, do you know what would be very, let's say, demanding for every drug to prove before? So if you have a candidate, like you optimize some structure, and then you want to see if it will react with DNA or not, right? So how is this property of a drug called? Do you know? Okay, I will not lose my time. It is something called mutagenicity. So to prove that some drug is mutagen or not, this is very important. If it is not mutagen, of course, then it can become a good candidate for a drug. So I finished with my questions. Thank you for your answers and for your work. Again, congratulations, and I give my words to next expert. Thank you.
Thanks. Thank you, Luke. Thank you very much. Who is the next one? Valeria Vladislavskaya, you are the next one. Don't forget that we don't have much time for the questions.
Okay. Hello, everybody. Dear students and tutor, thank you for very interesting research. And I have a short question for you. As a psychologist, I want to ask, do antimicrobials influence on our psychic? I mean, nervous system. Thank you. Yes.
Your answers, please. So, do the antimicrobials
influence on our...
Antimicrobials are made of proteins. That's what we have said. So the nervous system is included in the body. It could have a side effect, yes. But also as a drug, we will listen the word drug. Do you think it's something bad? It's something psychic a little bit. But there's the effect we made in the body to make an antibiotic to function is mainly the gastrointestinal things.
Thank you very much. I wish you luck and very good things. Bye-bye.
Thank you very much. Thank you very much. Who comes next? Danica? Maybe you?
Yeah, I'll be quick. So congratulations for your presentation. It was really awesome. I really liked it and it was interesting from my point of view. I would just like to ask you, so if you would go and test these candidates that you made, I'm sure that you made a good estimate based on the affinity and then you checked whether you can connect it to the enzyme that you're targeting, but then how would you go to test it if you cannot start with humans because of what Hook just said, and then actually what the previous expert also mentioned because of that gut-brain axis that exists? How would you go and test it? What would be your next step if you would have millions of euros and a laboratory at your disposal?
I think we need a first preclinical research to continue this investigation.
Okay, so that would be computational.
It's so important to be selective with the drugs.
Yeah, so we have drug development has different phases, and the first one, which is in vivo, it is in vitro, meaning we have to test it first under the laboratory experiments. So before going on to human subjects, we have to test it first through laboratory techniques.
Okay, great. Thanks for your answers and congratulations once more to all the students and the tutors as well.
Thanks, Danica. And we have one more hand from Oleg Kolesnikov. This is an expert we haven't presented. He's a teacher from Kolmogorov School of the Moscow State University. Oleg, please, your question.
Hello, dear colleagues. It was very interesting report. It was like the works of my student in AISC some time ago. And the question is, let we discuss biochemical level of your work. You demonstrated some structures of your proposed compounds, binding of these compounds in the active site of enzyme, yes? Well, and that interesting. You discussed some interactions, some fundamental interactions of your compounds with the enzyme amino acids, yes? Local hydrogen bonds, PP interactions, etc. Could you estimate which type of interactions for your compounds is mostly attractive? Have the most value for the binding of your compounds in the active site? Could you estimate which is more important?
I think your answer would be hydrogen bonds.
Hydrogen bonds. You see that in your compounds we have 1, 2, 3, not more polar groups. Yes, as I see. And which interaction will be enough good to add to hydrogen bonds? Hydrogen bonds is too small for you in water media. Yes.
Sorry, I didn't understand you. Can you repeat?
Hydrogen bonds. You are right. Hydrogen bonds. It's very great value for binding, but in new compounds we have not more groups for it. Not the sugars, not the another amino acids, but mostly hydrophobic compounds. Yes, and what you can say to add?
Okay, so I think I forget the there are hydrogen bonds and PP interactions together they make the best interaction for.
You're right, PP interactions, but I looked for your structures and found out the PP interactions only 2 of 4 structures. Maybe it was not correct. Maybe it is, I missed something, but to my mind, from my experience, it should present in every your compounds with the big aromatic systems. Yes, try to fit the structures to reach it. In other case, your proposed structures is not looking not so accurate. Yes, it should be in your structures, PP interactions. Try to find out it, please. Maybe by comparison with the same structures from the another enzymes, we have thousands of structures with the binded small molecules. Well, compare it, please, and it may improve your work. Good luck.
Okay, thank you very much. Thanks for these things. But unfortunately, we are out of the time limits. And well, Oleg, if you have any feedback, or just anyone wants to have a feedback, please write it in the questionnaire, or you can write directly to the group members, and we'll probably get to the next project by now, because we are out of the time limit. And next comes the project's investigations on defects in cathodes materials for the lithium-ion batteries. Project. Okay, let me remind you again about the QR code and the link. And now I'm giving the word to the group members. Please take the stage.
Can I share a screen?
Yes, you can show the screen.
Yes. I can start. I'm sorry?
Excuse me, could you just please correct the link?
And what's wrong with the link?
The questionnaire is for a different project.
The questionnaire is for a different project. Yeah, we will correct it. There is another link. And how about the QR code? Is it correct?
Hello, everyone. The project that we are going to present is called Investigation in Cathode Materials for Lithium-Ion Batteries. The team members are Shayan Mohammad Ali, Ivan Parsa Evegni, Nadia Tatiana Irati, and our tutor is Irina Merlamova. The aim of the project is to investigate the possible cathode materials and defects within them. To start, what is a battery? A battery is a chemical device that converts stored chemical energy into direct current electric energy. Its components are cathode, anode, electrolyte, and separator. Every single component is essential as it cannot function when one of the components is missing. High power density, long life, low self-discharge, low maintenance cost, and low environmental impact are the most important properties of a battery. There are different types of batteries. Primary batteries are one of the simple and convenient sources of power. Secondary batteries that can be electrically recharged after discharge. The most commonly used are nickel-cadmium, nickel metal hydride, lead acid, and lithium ion. Lithium is the primary source of lithium-ion battery, and it is more stable and safer in charging and discharging energy compared to other minerals. Development of advanced rechargeable lithium-ion batteries is one of the most important challenges of modern technology. This type of batteries is the most prospective due to their high energy density, enhanced rate capabilities, and superior safety features.
The secondary batteries has the different chemical compositions. It can be a lead oxide, nickel cobalt, or lithium ion batteries. Today, the most common of use is lithium ion batteries, and this type of battery can have different cathode materials, and depending on the cathode materials, the properties of battery can be different. The methods of synthesis of cathode materials can be different: solid phase, Sol-Gale, or hydrothermal methods, which is in common of use today. And the materials as well, and the cathode materials can have a defect. It can be substitutional, interstitial, vacancy, or cation disorder. And in current work, we will study the different types of defect in our cathode materials, especially the substitutional defect.
Okay, after reading the article you see on your slide right now, we answered some questions that you also can see on the slide. For the answers that I'm gonna say right now, answer for the first question, the method that was used to synthesize lithium ferrum phosphate is hydrothermal method. Hydrothermal method is a very common method of making nanomaterials. Basically, water is being heated up above its point of boiling, and thus the pressure within the reaction autoclave is dramatically increased above atmospheric pressure. That helps people to make highly crystalline materials without the need of post-annealing treatments. Okay, for the second question, the answer is in the article, there were 9 samples that were used, and the main difference between them was the concentration of solution of lithium ferrum phosphate. Now to the methods, which is the next slide, and yeah, just.
Okay, experimental methods. Mass spectroscopy used to determine the electronic structure of the atom in the material. This method was used for determine the valency of iron atom. Powder X-ray diffraction used to determine the atomic structure. This method is based on the phenomenon of X-ray diffraction on a 3-dimensional crystal lattice. Infrared spectroscopy used to conclusion is made about the structure of the sample. This method was used to find the OH bond in lithium iron phosphate structure defect observation.
So because of the pandemic, we couldn't prepare experiments for our project, so we decided to run simulation and investigate its results in order to reach our goal. So there could be several questions about our simulations. For example, what source is used for downloading the atomic structures of materials? So for this question, we use the materials project website, as you can see in the screen. And in this website, you can basically find any chemical compositions. And also, as you can see, there is an initial screen from the, as you can see in the presentation. So we can basically choose the elements that are included in our composition, and then basically choose them from the periodic table. And moving to the next question, as you can see, what type of files we use on the material modeling? So there are many file formats for downloading a chemical model, and one of them can be CIF or Postcard or XYZ. These are basically some file formats, and we use them to download a chemical model. Now, as you can see in this picture, basically, if I want to explain in the like programming aspects, a file usually has the necessary parameters of a chemical composition, which after we download a file like CIF file, we run it on JML application, which I'm gonna explain about it later. Now, which program we use for the visualization of our structure. So as you can see in this picture, we use the JML program to run our models, like chemical models, as you can see. And once we downloaded our chemical model from the materials project website, we run the file in JML, and we can start to investigate the structure and the model of our chemical composition. Now let's go to the next slide, as you can see. So this is basically the structure of a composition called lithium iron phosphate. So in this picture, we actually investigate our defects in lithium iron phosphate, because this material is a perfect material for our cathode part of our battery. And in this video, as you can see, you can actually ask a question, and the question is that what are the crystallographic properties of a material, as you can see in the picture. Now you can see a phosphorus atom in the center inside a yellow tetrahedral made of oxygen, and around that you can see 4 lithium atoms and 5 iron atoms, all surrounded in oxygen octahedrals. These are basically our hydro environments around lithium atom or iron atom. So the crystallographic properties in this video basically depict the hydro environments around either an iron atom or a lithium atom. Now, in this video, like in the last video, we saw the structure of our composition, like the basic structure. And in this video, we see the basic structure, but with phosphorus vacancy in the middle. And as you can see, the video shows the same model, but the model doesn't include the middle phosphorus atom and has a phosphorus vacancy instead. So yes.
Okay, so actually, because JMOL couldn't simulate the whole process of substitutional defects in the lithium iron phosphate, we actually used a Python-based code called Seaman. You can see it right on your slide. And what we did with this code, first we determined the unit cell parameters. For that, we used the code on the left of the slide. Then we deleted the phosphorus atom. Why we did that is we actually needed to simulate the distribution of hydrogen around first oxygen in vacancy polyhedral. Then we used the code on the right of the screen, the right of the screen, to create the distribution of oxygen around the hydrogen of around the oxygen atom. Then we repeated those steps. This code on the right is actually only for like one atom. So actually, we repeated that. For one atom of oxygen, and we repeated that 4 times because the polyhedral that was surrounding the phosphorus included 4 atoms of oxygen. So in the end, we will show you the results of the simulation.
So here is the structure of lithium iron phosphate. If you see, there are some polyhedrals around the atom of this molecule. For instance, brown ones are for iron's atom, and the purple ones are for lithium atoms. So this structure shows us the phosphor vacancy, that we have removed it and replaced it with hydrogens, as you see in the video. If we do this replacement, battery would have more energy. Next slide, please. The slide isn't coming for me.
Yes, and in
what should we do? Which slide?
Do you see this slide with colorized hydrogen?
Yes.
Okay. The color of hydrogen depends of its energy, and the blue colors mean the appropriate localization of hydrogen with low energy, and red color indicates the inappropriate localization of hydrogen near lithium or iron atom. It indicates the distribution of our defects in structure, and more appropriate of localization of hydrogen is in empty polyhedrals. And we can go to conclusions. And who will present this slide? Muhammad Ali?
Yes, and in conclusion, first of all, a defect can affect the material properties. Thus, their investigation is extremely important for science and technology. After that, it's really difficult to observe oxygen-hydrogen bonds in the experiment, so the computational methods are used. Next one, the process of modeling the defect within lithium iron phosphate is corrected step-by-step distribution of hydrogen atom is many possible positions and determine their energies in these positions. And the last of all, the structure investigation was realized in the current work. We can determine the morphology of substitutional V2 for hydrogen defect using programming tools. Thanks for your attention.
Okay, thank you very much. A few things I would like to say before we get to the questions. First of all, I absolutely must say that a lot of students from Iran have a lot of connection problems. They have problems connecting to Zoom, and generally they have some natural disasters. So some of them have very bad connections at the moment. So that's why the tutors had to interfere, because the internet was lagging with 2 people. But to everybody else, I would like to remind that if you speak, when you speak, please turn on the cameras, and please check the way you sound. You may be too soft, too quiet, and we won't be able to hear you. It is very important that you check this before speaking. Okay, and now, ladies and gentlemen, you are welcome to ask questions. Yeah, and again, you can see the link, the QR code. Are there any participants? Are there any students to ask questions? Again, we have Vuk here, but do we have any students? Okay, can you be more active, a little bit more active? Even if you want to make sure about something or didn't understand something, please ask the questions. It's important for the people who have prepared the project. Okay, Vuk, please ask your question then. Yeah, since nobody wants to do that.
Okay, thank you. Perhaps my question will stimulate, motivate someone else also to ask a question. So yeah, thank you for the interesting presentation. This is also something that is very important to do research on, new ways of getting the energy, right? So I would like to ask a question. So if I understood well, you took basically 2 unit cells, 1 unit cell of a crystal with atom of phosphorus and another unit cell of crystal where you don't have this atom of phosphorus. Okay, but so how, so if you have defects in a crystal structure, how this defect has influence on the whole properties of the materials. So this is something, is that something that you can also predict with some kind of software, or because just when you compare these two, I mean, you see what I mean? So could anyone comment on this? Is there a way actually to predict a property of the whole material depending on, for example, varying the number of defects, I don't know, 1 defect without phosphorus, let's say on, I don't know, 100 unit cells with phosphorus, and what would then happen with, I don't know, conductivity or other important parameters? You see what I mean?
Can I give a comment as a tutor?
Yes.
Okay, I can?
The rule is that the
If you want.
participants normally answer the questions, not the tutor.
I would like to ask, yeah, I
Okay.
would like to see opinion of participants and to see how they think about this question that I have.
Yes.
It doesn't have to be necessarily correct answer. It's just that I want to see how they think about this.
Okay.
On what they did within the project.
Okay, I'm okay to answer it. So I think we basically used some simulation and softwares, as you said, and these softwares require Python programming, and someone who has skills in programming with Python can basically use these simulations, and that simulation would give him some results, and like the possible coordinates of a defect to happen in our structure. So yes.
So can I give a comment?
I wanted to talk about the defects that the substitutional defect may affect on the battery. Basically, it may affect the lifespan of the battery, or I mean, mostly the lifespan, I guess. The lifespan of the battery, its amount of charge. I don't know the correct word for that. Basically, it affects the efficiency of the battery itself. That's yeah, just and yeah, well, no, and end of the speech.
Okay, thank you. Yes, Irina, please.
Yes, I need to give a comment about the task of my team members. We have a task to create a structure of our defect, to know the morphology of this defect within structure, because it is a first step for the biggest task to understand the influence of this defect to properties of material, of cathode material, and the properties of battery as well. As you seen in this presentation, we write a programming code to simulate the defect, to understand the morphology and localization, and we need to write the same code, the code to understand the properties. For example, electronic properties of material, the first step of investigation of properties of material, and the properties of battery with defective cathode is a more experimental task, because it depends on different part of battery.
So yeah,
Sure. Yeah, I was just wondering how participants think about this. I understood the task of the project, but
yeah,
was
so it wasn't
thinking
about
about
the
further work perspective developments.
yeah, so the whole research wasn't about the predicting on the amount of defects in I guess 100 of batteries made. It was actually about why is that why is that defect occurs, and the
Okay,
affection.
so why this defect occurs?
Because of the hydrothermal synthesis when the cathode material is being made. Um, well, as I told you that well, as I said, to actually make cathode material, manufacturers use hydrothermal method to produce it, because it's very easy and it doesn't require that much time to do. So because of the interaction of water and lithium iron phosphate, sometimes the substitutional, well, basically the occurrence of OH bond occurs when lithium iron phosphate and water that is being heated up, well, the heated up water are in contact, the OH bond creates in the lithium iron phosphate, and that's why the substitutional defect happens.
Yeah, okay, great. And just my last very short question, what would you do to, for example, increase number of defects in crystal that you would like experimentally to make? For example, you want to have lots of phosphorus missing in a crystal. So what would you
Excuse
do?
me?
Yes.
Can I answer this one? I would be glad to. Okay,
sure.
thank
Yeah,
you.
please.
So basically, it really depends on the amount of our each element's vacancy rate actually. So you
Yes.
see, phosphorus vacancy is phosphorus has a very high vacancy rate, and once phosphorus vacancy occurs, hydrogen atoms start to like the defect occurs by hydrogen atoms placing near our lithium atoms and our iron atoms, and this is basically what happens when our defect is happening. What I mean is that the hydrogen atoms basically are the roles for a defect to happen, and in order to increase the amount of defects, we have to choose elements that has a very high vacancy rate. So the hydrogen atoms, like the more hydrogen atoms would get absorbed to our chemical structure and placed near our iron atoms. So we would have a very good very good amount of defects.
Okay, thank you.
Thanks, Vuk. Well, if there are no more questions, I see no hands there. So please, maybe you have some feedback, maybe not just questions, maybe some comments. Maybe some comments. No? Some feedback? No? No?
No. How good is that? No comments at all. Our presentation was perfect, and we presented it perfect.
Yeah, do you want me to give a comment? or no, because my comment is really positive. I think it's, as I said already, it's really positive, and it's something that we should be doing research on. It's something that's, let's say, also a bit perhaps difficult to understand, because research in this area is very specific, and you have to be, let's say, good in physics, chemistry, and mathematics to understand, to do good research in this. So it is really good, and also in programming, which is like completely separate thing. So I think it is really, this project was really demanding, and congratulations to participants on the work they have done.
Thank you very much.
I have a hand from Danica again.
Yeah. So I was just reminded, well, actually, I was wondering during this presentation whether there is any limitation to this kind of method of developing, new compounds for batteries because of the simulation running time. So how hard is this to run? How complicated and how long are the computations?
Do you mean the calculations and how long they run?
Yeah, exactly.
Well, basically, we did the calculations.
Plus machine, of course.
Yeah, well, with machine, I mean, yeah, but we did it on the well, actually, we had the results prepared, but as our tutor said, as our tutor said, the duration of calculations may last to from like from several hours to, I don't know, 1 month, I guess, as I was said. But I mean, it's a very long process.
Okay, so you weren't running any simulations on your own. You were analyzing the results of simulations.
Kinda, yeah.
Okay,
Kinda.
okay, fine. I didn't get
because the calculations are being run on the separate server, so that's why it takes so long for it to run.
Okay, so my assumption that it's quite computationally heavy was correct, and it's actually a limiting factor, although it's still much better than trying it out in the lab, I must say. I would just like to use the opportunity when I'm talking to give word to Yamal, who asked if they can give a comment.
Yeah, just I wanted to give a comment.
Go for it.
that the project was great because it shows not only the knowledge of English but the knowledge of different spheres, but the book has already said that. So that's great. Thank you very much for that kind of project.
Okay, if you want to say something, please raise your hand next time, because otherwise it's very hard for me to watch everything, the chat and everything. So please raise your hand, okay? All right, thank you very much. I think we can get to the next project, and thanks again to the previous one. So next, we have mapping and predicting the methane emissions in the Arctic. Again, let me remind you about the QR code and the link. And now I'm happy to invite the group to take the stage. Please do it.
Yeah, hello there. Hello. Can you hear me? Yeah, good. I'm waiting for my friend to present. 1 second, please. Yeah.
Okay, we can't hear anything.
Gonzalo, are
sorry,
you here?
Sorry. Yes, I was configuring the share. But hi, I'm Gonzalo, and my two mates and I will show our results about mapping and predicting methane emissions in the Arctic. The Arctic region. The Arctic region is all the land above 66 degrees north that comprise the Arctic Sea, its island, and its coasts. There are big oil fields between Barents and Kara Sea, and in areas of northern Siberia, like the Yamal Peninsula and northern Alaska. The Arctic region is mainly composed of low-lying terrain and marshes with a seasonal or year-round layer of permafrost. Below the surface, we can expect sand, mud, clays, and mixtures of these materials. The climate and energy balance. The Arctic is a pretty cold place, averaging minus 34 degrees in winter and only from 3 to 12 in summer. This causes a lot of snow to accumulate in winter and partially melt in summer. In the picture above, the dark blue approximately corresponds to the snow cover. All this snow is very important for dissipating solar radiation because of the snow's high albedo, and as the left map shows, the Arctic and Antarctic have the less radiation in all the globe.
Okay, that's my part. Hello everyone. We can take next card. Okay. If we wanted to know eternal structure of the Earth, we must have any type of methods. The simplest method that with it we work, it was the VS method. This method based on direct current. He must have 4 grounded electrodes. And if we work at field survey, the electrical survey Equipment setup is performed at the selected area, still fielding electrodes of the first shortest installation distance are grounded, and the brass measuring electrodes connected to the measure are grounded. The supply line AAB current is set by the operator based on the instrument readings. Okay, the next method, it's a very interesting method for me. This method can give for all of us very beautiful maps of structure of Earth. It's the ART method. This method based by a principle SVS and need a lot of complicated calculation. This method can be used almost anywhere. The next. The second method is the Tdm method. It's a very good method for situation when we must have geology section according to the data of. This method working with two antennas. It's a generator loop and a central record and measuring loop. On a generated loop, generator gave any waves that take measuring loop. Okay, that's all.
So yeah, now to the fun part and to the results part. So first of all, we chose an Arctic environment that we're gonna study and analyze. So we chose that red spot in the Arctic Ocean to study. If we zoom in a little, we'll find like 3 nearby lines next to each other, which are our 3 profiles that we're gonna work on. So when we look more deep into the environment, we notice that we have 4 similar layers in each one of the profiles, which are from top to bottom. We find water, then clay, then sand, then frozen rocks or permafrost. So our next step was to take those 4 layers and search for the sensitivity of each one of them, because we'll need it in our calculations. So as we can see the table, those are the resistivities with ohm per meter, but those aren't the 100% and the exact accurate numbers, but they are approximate numbers, because in order to find the 100% accuracy, we need to measure with the methods that Daniel spoke about, or we need to calibrate with an actual geological data. Okay, so then we had to make some calculations and fix our models and profiles, which can be helped with softwares like Tdm, which allows us to set our sensitivity and calculate our layer depth and much more options. So starting by the first profiles, which was the line on the south, we put our approximate resistivities and run the programs. And yeah, as we can see the results in the picture. So we have like the 15 meter depth for water, then 15 meter depth for clay, then 80 for the sand, and then we'll have the last would be frozen rocks. Those numbers themselves, like the table, wouldn't like make any sense itself. So we needed to learn some geology and link it with our results and numbers in order to get something useful and something that we can explain. So yeah, as we can see in the picture, those are how our layers are constructed from what we've learned. And then we go to the second line, which was the line in the middle. And this line was like the most interesting out of them because it had specifically higher resistivity. And after looking for the reason of this high resistivity and linking our results with geology again, we noticed that we had a gas set in that specific layer in the middle. Because that's what made the resistivities get higher. So yeah, then to our third and last profile, we had nothing special with it. It was just like the first profile, saying similar resistivities and yeah, similar depth. And yeah, this is how the last profile would look. Those are how the layers would look. We have like usual water, clay, sand, frozen rocks, and they are almost similar to the first profile. So yeah, that's all. Thanks for your attention, everyone, and special thanks to our instructors. Thank you.
Thank you very much. Thank you very much. Now you are welcome to ask questions. So this time we have quite a few people who has their hands. Do we have any participants? Why don't participants ask questions? Why don't participants ask questions? Well, okay. So, do we have any participants? No, we don't. No, we don't. Then who was the first? I think. Okay, Irina Repina.
Oh. Unfortunately, I was a little late. My name is Irina Repina. I am from Institute of Atmospheric Physics. And I am glad to hear a report where I can feel like an expert, because we study the methane and CO2 emission in Arctic region. And now I have some questions. This report was very interesting to me. My thanks to research team. And what do you call the Arctic? Is it just the Arctic Ocean or surrounding area too? I have a question. I can ask all questions, but no, ask me. Ask me on the question.
You mean answer?
So the question was like, if we studied the whole Arctic or that specific part, or I didn't quite well get it.
Oh, let me explain. I think I understand. So the question was very simple. What do you call Arctic? Just the ocean or everything around?
With permafrost, wetlands.
I think yeah, we call Arctic isn't the small ocean. It's like a whole region constructed of many countries, like small part of Russia, some of Greenland, Iceland. That's what answers the question, I guess.
And you haven't said anything about why methane reach is so important, and what is happening to it in the Arctic now. Why is it a great topic, the methane in Arctic?
Because all these gas emissions have like a very, very strong gas. For the global heating, it has a very strong effect as a greenhouse gas. And also it makes like in the ocean, it can sink ships if passes like in that spot that we show that has a gas column, and cause the water density to drop, and if a ship passes over, it can sink.
And what do you think are the reasons for the increase in methane concentration in the Arctic? Are you considering only ocean reasons?
It's principally in the ocean, but it can also be in very low lying zones of the tundra, like the shores of the Arctic Sea also.
But I will tell you right away that there are three versions. The methane carry out by rivers. Methane is increasing due to the thawing of permafrost. The second reason, emission from the ocean. From the ocean floor due to destabilization of methane hydrate. And the third version is atmospheric transport from lower latitude. Do you know about these versions?
Actually, it's a question for me. We were only discussing questions of permafrost, how it's thawing, and how sea could be formed from the gas fields. I mean, due to reducage of permafrost.
And last question is yes, I understand you use only vessel data, shipping data, and there is a lot of satellite data. There is the satellite mission that permit to see the concentration of gas about all Arctic area. It is seem to me that satellite data is more suitable for making maps.
That's once again for me. We had our course about geophysical data, and I mean the geophysical data we could obtain from the sea directly, because I work with this data, so it was more about how to find the seep in the sea, not about how to make a map of the whole Arctic. Of course, if you make a map, it's more important to use satellite data because you have like the whole vision, but this wasn't the purpose of our project.
So thank you. That's all. I will give the opportunity to give question any people. Thank you.
Thanks a lot. Yeah, I would like to urge experts not to be too long and to ask many questions, because we have very many people who want to ask questions. So please try to make it a bit shorter. So the next one will probably be Andrei Kashurski, yeah? Kashurnikov, yeah?
Yes, thank you. I have a short question. Question is, how many solutions does inverse geophysical task? How many? One solution, two solutions, three solutions? What do you think?
You mean like the methods we can use like the VS and stuff like that?
Yes.
Yes, from what we studied three methods, which are the VES method and the ERT, and finally the TDM method. Those are the three we studied, but we spoke about some more in it.
Yes, thank you. Thank you. It's all.
Thank you very much. Well, Ivan Smirnov, please.
Thank you for your presentation and for your answers. I have a short question. And what's the conclusion of your research? And what you can say about the processes that we can see in Arctic due to global climate changes? And what your research can say about it? Thank you.
Well, I think that our research makes like detecting the methane and gases much more easier with like the methods we learned instead of like, for example, bringing a drill and drilling everywhere to detect gas on fields of oil or gas. So like the methods we learned and the methods we use make this stuff much easier.
Thank you.
Okay, Ivan, are you satisfied with this answer? Is it all right?
But we can
Okay.
discuss it later, I think. Thank you.
Okay. Ivana Gapkin, please. We have some 5 minutes left.
Hello, thank you for your presentation. I was quite impressed that students from school can study with patients such a quite unique topic, because I knew something about this only when I entered an university. So my question is, after this research, anybody from your team, do you want to continue your study, your future study in geoscience?
Speaking about myself, it's like I found it. I didn't have like previous much information about it, but in this course, I like loved it a lot, and I'm really interested in it. I didn't yet set a goal in studying it, but I might. It's really interesting.
What about me? In the future, I wanted to work how ecology research and work with our soil and, for example, methane. It's very interesting for me if I work how ecology. And nowadays, it's very important for all the Earth.
For me, I think it's very interesting for me, and I'm interested in searching how we can make new things with all these vast region that it's the Arctic, that now with the climate change, it's like being more habitable and to develop new things there.
Thank you. I wish you luck in your future science career way.
Okay, thank you. Timothy Erlo, please.
Yes, hello, and I have very short question. And how have you verified your data? How have you verified your conclusions? Maybe you have some measurements, additional measurements that you can verify your GPR analysis and other results.
So I will answer for guys because
independent management.
I mean, there were no independent measurements. Actually, we had troubles with software. I couldn't get the full version of the program, so I had to even cut a big piece of profile and just leave a few spots. So
okay.
All the verification is based on, like Peter told us.
Okay, thank you.
Okay, Valeria Vladislavska, please.
Okay, thank you. There is one international organization, Arctic Council. Do you know about this organization? And if you don't know, I recommend you to read about it because it's this information is very useful for. So my question is, do you know about Arctic Council, international organization, and what is the role of this organization in your topic, in your theme? Thank you. Thanks for your research, very interesting and actual.
That was a bit too quiet.
Sorry, I mean, there is an international organization, Arctic Council, and do students know about this organization, and what is the role of this organization in their theme, in their topic? Thank you.
Thank you.
Okay.
Yeah, I heard the question. I'll let Daniel speak. You can go.
Okay. What about me? I don't know nowadays about this organization, and I wanted to work in this group because I have interesting in this type of life, Arctic and all our country. And thank you for this organization. I wanted to know more about this. Thank you very much.
For me, I think I've heard about it. I don't know much, but I've heard about it. I think it's responsible for environmental protection in the Arctic and stuff like that. But I don't know much about it, to be honest.
Yeah, I recommend you. Thank you, and I wish you luck.
Vuk, are you there?
Yeah, sorry, I had a short interruption. So yeah, I think you told me one question. Yeah, because I have 0 minutes to ask my questions, but actually my questions were focused on the research and your project. So I will just ask, I have 3 questions. I will just ask all of them. And then if you know answer, you answer. If you don't know, you will then just think about it and for yourself. So I'm not a geologist expert, I'm a chemist. So there are a couple of things that I didn't understand from your presentation. So it might be that you well did this and you understand it, but for me as a listener, I did not completely understand. So the 3 things I didn't understand are the following. So you said, first thing, if we zoom, we can see 3 parallel lines. I have no idea what you zoomed and what these 3 parallel lines represent and why is this important for your research. Second thing that I didn't understand is how is the layer resistivity connected to methane emission. And the third thing is you said we noticed that there is a gas seep between 2 layers. So how did you notice this? You had to measure this, you had to use some technique, method, comparison, calculation, modeling, whatever to notice this. So these are my questions. Thank you.
Yeah, I can answer some of them. For the zoom something, we chose like an environment in the ocean, and then like we zoomed on the Google Earth map. Like we already prepared it, so it's just we can see it. And for the last question, I think
but what were these 3 parallel lines then?
It's like an environment that we chose, like kind of random.
Okay, it was just something interesting you saw in the sea, and then
the samples are the samples. We based all the program and all the investigation. It's all the in that place. It's the place from where we.
Okay, I see
the data.
Okay, so 3 lines, like someone already took some samples from there, and that is why there are 3 lines, because 3 samples were taken from 3 places. Okay, thank you. Second, third, quick answers.
What was the third question again? Really?
Third question, how did you notice that there is a gas seep between 2 layers?
Because like when the resistivity of our elements, like the water, for example, we saw that it augmented and raised from, for example, it was 2, we were working with 2, and then in that specific layer, our resistivity raised to 20 per meter, for example. And from our geology knowledge, we know that there is gas merged with it, which raises it.
I see. Yeah.
Its
okay.
resistivity.
Thanks. Okay, yeah, this answered the question too as well. Thank you. Good project.
Oh, thank you very much. And well, thanks to the project, it attracted a lot of attention, which means it's a success. And now I think we can get to the last one today. It's genome study of the bovine herpes. Again, let me remind you about the QR code and the link. Yeah, and the members of the project, Genome, the Genome project, please take the stage. We can't see your screen, unfortunately. Can you show us your presentation because we can't see? Ah, yeah, now we can. Is anybody going to start speaking?
Yes.
Then turn on the camera. If you want to speak, please turn on the camera.
Okay. And
1 second, please.
Okay.
Again, we can't see your presentation. If you have any technical difficulties, we can show the presentation ourselves. What's wrong with that? We saw your presentation just a minute ago and now we can't. What's wrong? We can ask our technical experts to show it. Hello, will you say something? Okay, if you can't do it, okay. Okay, now, let's go. You can start speaking.
Okay. Welcome. We want to present our project genome study of bovine herpes virus.
Next slide, please. So, bioinformatics is a science that studies the patterns of the genetic code, uses them to analyze, compare, search for drugs in silico using mathematical and statistical methods. Next.
In biology, a gene is a basic unit of hierarchy and a sequence of nucleotide in DNA or RNA that encodes the synthesis of a gene product, either an RNA or protein. During gene expression, the DNA is first copied into RNA. Next.
For bioinformatics, it is important that DNA contains adenine, guanine, cytosine, thymine, and in RNA, instead of thymine is uracil. DNA, the second helix, stores Hertzian information. Next, please.
The picture shows the difference between DNA and RNA. And next.
So proteins perform a wide range of function for the cell. They help in metabolism by providing structural support and acting as enzymes, carriers, or harmonies.
Next. Two main processes in which DNA and RNA are involved. Replication, the basic of self-multiplication. And translation, protein synthesis or an mRNA. And next. In the picture, we can see the synthesis of ribosome in eukaryotic cells. Next.
The object of my part of the research is alkane nuclease, deoxyribonuclease. It's a phosphodiesterase capable of cleaving at phosphodiester internal bonds within a DNA or RNA substrate. It plays a role in processing branches viral DNA intermediates in order to promote the production of mature progeny, viral DNA molecules. The next slide, please. Thank you. Its molecular functions are endonuclease and exonuclease, etc. In short, it's splitting of DNA in certain places. The next, please. By using the alignment method, which graph you can see in the lower right corner, I managed to find herpes viruses with a similar genome of alkane nuclease. There are 71 of them in total, and only 9 are particularly similar to investigated objects, but they are all artificial with synthetic gene and DNA. Similar objects are shown at the top of the slide. The lower left corner shows the lineage of the organism. Its pharmacological action is that it delays the development of viruses that contain DNA. By suppressing the synthesis of viral DNA, it doesn't damage the DNA of organism cells. It has an antiviral effect. The next, please.
So I'm gonna start from what is genome. It's all the DNA in a holoploid cell, all the DNA on all the chromosomes. It includes the sequence of each chromosomes plus any DNA in organelles. And most genomes are made of DNA, but a few viruses have RNA. And eukaryotes have genomes too, like nuclear genomes, mitochondrial genomes, and plants have plastic genomes. And if not specified genome, usually refers to nuclear genome. Next.
So you might be wondering what a bovine herpes virus is. It's a DNA virus, so it possesses double-stranded DNA, and it's also an enveloped virus, which means it has a protective outermost layer. It causes several diseases worldwide in cattle, which means cows and bulls, and it is a contributing factor in shipping fever, which is immensely important since it causes infections that can affect trade restrictions, as well as be a source of economic loss in the dairy and the beef industries.
So what's next? Why have you stopped?
I want you to finish, Roman.
Wants me to finish.
There's
definitely.
Can you open the next slide, please?
Okay.
The Iranian students are presenting, and they have some connection problems.
Okay. Now, can you hear me?
Yeah, we can.
Yes, we can. We can. You can see.
So now you should know how to analyze the genes. We use 3 websites actually. The first one is NCBI, National Center of Biotechnology Information, that we use for blasting the DNA sequences and proteins. Next slide, please. And the second one is Clustal W. Clustal Omega is a new multi-sequence alignment program that uses seeded guide trees and H&M profile techniques to generate alignments between 3 or more sequences, as you can see in the pictures too. Next slide, please. And the third and the last one is MIMI. MIMI discovers novel ungapped motifs in your sequences, actually. MIMI splits variable length patterns into 2 or more separate motifs. See this picture for more information, as you can see.
Our group did research on 2 virus-specific proteins, envelope glycoprotein E and envelope glycoprotein B, and also on an non-virus specific protein called ribonucleoside diphosphate reductase small subunit. You can see some of our results, some of our BLAST results on the slides. On the next slides, right.
So what comes next?
And next slides, please.
Okay.
Next slide. Just keep sliding.
Is this the correct one?
Just keep sliding, please. So unfortunately, Yana is not with us, as I can assume. So Yana is missing. One of our students is missing, and no one else is here to present. So I will explain her part. She was analyzing Tiguan proteins, which is a layer of proteins lying between the nucleocapsid of herpes virus and the envelope of the virus. Next slide, please. She was analyzing two types of Tiguan proteins, one that participates in accumulation of viral mRNAs, and the second one that can bind to various RNA transcripts and disrupt the translation of cells mRNA. Next slide, please. BLAST results are shown on the screen. Next slide, please. And as expected, no results were found in non-herpes virus sequences. So the only sequences with homologs for this gene were herpes virus sequences, which confirms that this is a virus-specific gene. Next slide, please. And her non-viral specific protein was uracil DNA glycosylase, which prevents the uracil from entering the viral DNA and prevents mutations in viral DNA in the process of viral DNA replication. Here are the results. As you can see, this is a common protein, not only connected with viruses. Next slide, please. You can see the phylogenetic tree, which tells us that one herpes virus is protein is closely related to some of the bacterial proteins. Next slide, please. And the proteins parts known as motifs confirm that as well. Next slide, please.
And we've already been told in details about the work done, so we would like to tell you about what genes did we work with, where did we work, and our impressions. Next slide, please. We took thymidine kinase. Next. Replication origin binding protein. Next. And capsid scaffold protein. Using the example of the capsid, we will show our work. Next. We worked in the BLAST, and here are results. Next, please. We worked in NCBI, and here are the results again. Next, please. And we worked in mimicide, and here are results. Next, please. And there are the trees of that site. Next, please. And here are the results of our whole work. And they're more colorful. Next.
Okay, now I want to talk about the envelope glycoprotein
I'm
type H.
sorry. Excuse me. I'm the member of the fourth group. Can I say some words?
Now we're continuing. We are on a timer.
Okay.
Sorry.
Can I continue?
Yes, please continue.
Okay, I wanted to talk about the envelope glycoprotein type H, but first I want to give you an introduction about the envelope glycoprotein viruses. In general, these types of envelope viruses actually form a membrane using the protein and lipids of the host cells when they enter the body. And by making this membrane, actually this envelope, the body cells accept it as themselves, so they go and attach to the virus. And we have so many types of the envelope glycoprotein viruses. As an example, glycoprotein type H, type P, type M, type O, and so many more. And each of them has a specific task. As an example, type H, its task is to do something to attach the host cell to the virus. Next slide, please. Now let's move on to one of the other types of the envelope glycoproteins. It's type M, and its task is to direct the glycoprotein N to the host Golgi network. Next slide, please. And now I wanted to talk about our last gene, which is a non-specific gene. As you see, the two previous genes were viruses, but this one is non-specific gene, deoxyribonucleic triphosphatase. And they're the molecular precursors of both DNA and RNA, which are chains of nucleotides made through the processes of DNA replication and transcription. Next slide, please. Okay, in this project, we learned how to analyze genes using so many different websites and tools, websites such as NCBI, such as Uniport, and so many more. Next slide, please. And now we want to share our results with you. As you can see, we have some BLAST results, which are some links to some similar genes to our gene. Next slide. We have some graphic summaries. Next one. And also we have a tree view, which shows which genes are similar and which genes are not similar. And we can realize this by looking how far or how close they are in the tree. And next slide. And also we have found some motifs, which are some amino acids in very different colors. And next one. And also one of the other websites called Clusterflow, and this is our results from that site. And as you can see, there are so many genes on the screen, and there are so many amino acids in front of them. And as you can see, there are some stars, dots, double dots, and spaces under the amino acids. And each of them has a specific meaning. As an example, the stars means that in these areas, we have some same amino acids. And we just have to think and look at them and realize why in some places we have so many stars, but in some places we don't have any, or we just only have one. And now I will give my talk to my friend. Next one, please.
Well, as envelope glycoproteins have already been discussed, I'd like to pay attention to a non-viral specific gene, Serine Protease, which is basically an enzyme that cleaves peptide bonds in proteins, in which serine serves as a nucleophilic amino acid at the active site. Next, please. To say more, while analyzing gene sequences, I have found out that bovine herpes virus and Salmonella enterica have a very similar gene sequence for serine protease, which, for instance, can be a result of a previous viral infection, as Salmonella started using viral protein in the genome. That is what the phylogram shows. Next, please. You can also see some other results there. Thank you.
Okay, thank you very much. That was very interesting. Now it's time for questions. The presentation took a bit longer than usual, so we probably have less time for questions, but just a bit less. It will depend totally on how many questions will we have. Maybe we will have a lot of questions, and so we will have to make it a bit longer. Again, the most active participant of today, Vuk, is still here. So, is there anybody else apart? We'll have two hands. Yes.
Okay, so yeah, as a leader of project, I'd like to say that unfortunately we have a different version of a presentation. So the students were reporting on the different presentation and the order was different of slides. So unfortunately, it's a bit of a technical problem. I was disconnected just for a minute as the presentation was starting, and we the wrong version was used. It's very unfortunate. I'm sorry.
Mm-hmm. Okay, thanks for explaining that. We have Zoran here. Zoran, well, your question, please. Zoran, are you there? Zoran.
Yes, I'm here, but I think Vuk asked the question first, so I would let Vuk ask the question.
So you will wait for Vuk to ask questions. Okay. All right.
Okay. As you wish, Zoran.
You go first.
Yeah, thank you. So I will have questions, but I also have a comment. I see that it was quite difficult to organize the work in this project because this was quite complex topic, and I think you have also quite a lot of participants here. So like very well done for organization of the product, and I think it was quite complex. But still, I would ask some of the participants to say, for example, when you say blast result, what does it mean? First question, or let it be second question. Let my first question be, if someone could explain in maximum of 5 sentences, what was the goal of your research, then to explain the result that you got, and its significant, how it is scientifically significant for, let's say, bovine industry. That would be my first question.
So BLAST is the site where we worked on.
Yes, okay. So what does it stand for? BLAST is?
Okay, I can explain that.
Is it? Yeah, but I think they should know what BLAST means, right?
Can I answer, please?
Yes.
Actually, the website that we used was NCBI, which has so many different parts, and one of its parts is BLAST. And actually, BLAST means that at first we found the genetic codes of our gene, and then we go and put the genetic codes on the BLAST website, and then we actually check some options that we like. For example, if we like to include the bovine herpes virus or not. And after that, it gives us some results, as you saw on the presentation. And the results are, for example, the graphic summary or the 3D, which I said shows which genes are similar and which are not, and also it shows some actually links to some genes which are similar to our gene, and yeah, it's kind of
okay. Yeah. Okay. So it is a tool. It is, if I'm not mistaken, basic local alignment search tool. So it is, let's say, software or something like that can help you compare or whatever, search for some kind of sequences in genomes, right? Okay, thanks. If Ekaterina would like to say something.
Well, putting it simpler, I see that you're probably a colleague of mine and you know what it does, but yes, basically it's a very advanced search tool that has an input sequence, and then it blasts this sequence, or just kind of compares some words in a sequence to the words in a database. So it finds the most similar sequences in a database to the sequence you input in. So it's basically a search tool which operates like Google, but with the genomic sequences. And the goal of our research was
Can just excuse me, for goals, I would like to hear some of participants, if possible.
The goal, the idea of our research is to identify various variants of viruses for their further use in medicine and pharmacy. Yes.
Okay, so how did you do this? Just in one sentence, you compared this, you had some sequences of proteins that are part of viruses, right? And then?
Yes, we made a research that can help our medics, our pharmacists to do some useful drugs new, I think.
Okay. So you were finding, like, let's say, virus-specific proteins in all of the variants of the virus.
No. We were finding variants of genes.
Variants
DNA.
of genes for these proteins.
The variants, yes, that can help.
I see. Okay. Anyone else from the team would like to comment? Like, let's say, why is this scientifically significant? Don't be shy.
Well, they are quite shy. Significant means important, if you don't understand.
Yeah, yes, important. Sorry, yes, perhaps. Why? So, yeah, why would you do a research like that? You mentioned that this is important for bovine, right? Yes, for beef industry, but yeah, how this relates to
I feel we're very unlucky, but I made quite a few lectures about this. Just remember what I said, and
okay, yes. Someone
there were
remembers.
quite a few lectures on this and how exactly can we apply the results of our research in the real work.
Okay. Anyone? If not, as we say in France, c'est pas grave. It's not something too big deal. So I will just then thank you again. Yes, this was a difficult project to understand, I think, at high school level. It's quite ambitious. I would congratulate to all the participants that were brave enough to enroll such project. So again, multidisciplinary, I guess, was important here. So Zoran, yeah, if you want to ask a question, thank you.
Okay, thanks, Luke. Thanks for being so active today. Well, Zoran.
Okay, I promise not to be. I promise I will be really short. Yeah, it's a really interesting project because I was doing pretty much something similar, of course, using the same tool. The question is it possible? So for you guys that did the project, is it possible to compare the gene structure from different species using the same tool? And if it is, how would you do it? And maybe short second question. If you find that your virus has mutated, would it be possible to find which part of the gene is mutated by using the same tool? And if it is, how?
Okay, are you ready to answer the questions? Is there anyone who can answer?
Let me just help.
Yeah.
You already used it.
As for me, I think yes, that with the help of these tools that we used, I think that we can make lots of research with many artificial, synthetic, and natural DNA. So the answer is maybe yes.
Good answer. Yeah, and just I want to say, Ekaterina, it was a really good. It's a really good idea that you found, and yeah, great project. I know it's a really complicated, but it's something really good. Perhaps maybe optimize it a little bit, but good.
Okay, thank you very much. Thanks, Zoran. We have one more hand, Sergey Levitsky. Yeah.
Dear colleagues, can you hear me?
Yeah.
Okay. Thank you for nice presentation. I have a very small question. As I understand, some proteins that you studied has great homology to bacterial proteins. How can you explain this? Is these proteins were transferred from viruses to bacteria or from bacteria to viruses? Thank you.
Okay, I can try to explain this because I have already done this during my speech. As I have already said, it can be a result of a previous viral infection. So the bacteria started using viral genes in the genome. So yes, firstly was bacteria started using the viral genes.
Okay, thank you. And can I ask one more question?
Sure.
You know, bioinformatics is a very interesting science, but it's rather far from biology. Can you say some words about life cycle of virus that you studied?
Okay, do you all understand the question? Sergey, did you mean how long does the virus live?
No, I asked about life cycle of the virus. How?
Okay. Mm-hmm.
Bioinformatics, I think sometimes is more informatics than
We thought that our students would have some previous knowledge about the basics of molecular biology. So otherwise it would be just a course of lectures.
Okay, thank you very much.
Okay. Well, this was the that was the last project today. We will have one tomorrow. Maybe some of the experts or maybe somebody else wants to give their feedback on what they have seen today. So yeah, we offer you an open mic. Okay, Luke.
Hello again.
Hello.
Yes, I'll be very short. So yes, I think I would again like to say a few words. Like really, I have been working remotely, so this means from home for a couple of months, so almost a year now, and I know how difficult it is, and difficult in many aspects. So. Again, congratulations to everyone who was involved in projects, organization. It is difficult with connections, everything, communication. It's really not easy, but yeah, everyone of you was brave enough to come deeply to like really go deeply in this project, in these circumstances, and this is amazing. So congrats to everyone on that. I would just like to say another comment. So during presentations, I heard sometimes that participants said, I found something or my result is. So just be careful when you're saying my result and when you're saying our result, because this is very important, especially when you come to, I don't know, presenting your research in an international conference, or for example, defending your own work, let's say PhD work or master's thesis or something like that, which also was probably part of some group, let's say research, right? So when you're presenting your own work, and it is important to emphasize your own work, as PhD thesis defense or master's thesis defense or some, let's say, seminary work at high school or at faculty, you can say, yes, my result, I found. But when you are working in a team, in a group, like it was a situation here, then it is we, then it is us, it is our result, and yeah, our achievement. So this is really important to stress, because it was not only you, right? You're part of the project, part of the group, just one piece. So don't forget the others. So yeah, that's all I had to say. Thanks again for nice presentations and effort in these difficult conditions to conduct the research.
Vuk, thank you very much. Thanks for being really so very active, and thanks for being so positive to the participants today, and for all your comments and questions as well. Thank you. There was also Danica, yeah, who wanted to say something.
Well, I really
Danica?
like the idea that book has of short things. My first comment is actually related to duration of presentations. So sometimes they say more, less is more. So meaning if you want to really communicate with your audience, and in this case, you try to teach your fellow participants, what did you learn, what did you discover, and what was the new thing that you found? I think that maybe it's more important to concentrate on somebody that can understand. So to put the content in a way that everyone that was at the IRS can understand. So starting from the organizers, going to the experts, to other tutors that are not from the same expertise, it would be really nice if everyone could learn from your presentation. So I think that was a bit missing this time. And of course, I appreciate the circumstances, which were definitely too hard for everyone, starting from the tutors and the time zones and organizers. I cannot even imagine. I'm sorry that I didn't participate this year, but I really admire what you did. So just as I would say, not for PhD thesis, because that's a bit far away for you guys, but anytime you present, just think about who is your audience, who are you trying to teach, who are you trying to communicate the message to, and try to, in general, be clear about your goals, clear about what was your research about, what did you want as an ideal outcome, and what did you really get. So you would have some kind of expectation from the audience. You say, okay, we hope to find a molecule that is perfectly fighting this bacteria. And then in the end, you say, okay, we found 4 candidates, and they're candidates because of this, this, and this. So I think that in some presentation, it was more pronounced. There was this kind of structure, and in others, that there could be improvements. But all in all of you, great work. Really just doing this kind of projects online in this crazy year, I think that's already a great feature. So congratulations to everybody, really. And thanks.
Thanks, Danica. We are missing you very much, as well as Vuk. Okay, we also have someone else to speak. It's Tatiana Bompe from the experts. Tatiana, are you ready to say something?
Yes, I would like to say words from the experts and also from the young scientists of Russian Academy of Sciences. We were very impressed to listen such brilliant work because we understand how it was difficult to make this job. Even you have not opportunity to make a real experiment, you make a good job while simulating some processes. So we're very impressed. So thank you very much for your job, and good luck in future and in science too. Thank you.
Okay, thank you very much. Thanks, Tatiana. And we are waiting for everyone tomorrow, except the experts, who we are waiting in 15 minutes for a short briefing to discuss what you have heard today.